Welcome to our today's lecture. Previously we have seen introduction to the metrology. Second unit we have seen comparators and standards. So today we are going to discuss about limit, fit, tolerances and gauges. So myself Mr. Bipin Patil, lecturer at Department of Mechanical Engineering at Charad Institute of Technology, Polytechnic, Yadra. So let us see today's content. So today we are going to learn about the concept of limit and fits, deviation and tolerances. Then we are going to see the basic terminology: normal size, basic size, actual size, zero line, hole, shaft, then hole designation, shaft designation. After that we are going to see what is meant by selective assembly, what is meant by interchangeability. So let us start with today's content. So as per the MSBT board question paper, this unit having marking weightage up to 12 to 16 marks. So as you can see on screen how exactly the representation of hole and shaft is done. Here you can see the number of parameters which are showing: upper limit of hole, lower limit of hole, actual size, basic size, upper limit of shaft, lower limit of shaft, and the presentation or graphical presentation of hole and shaft. So today we are going to discuss about the definition of limit, fit, and what is meant by tolerances. So let us see the definition of limit. So limit is, there are two permissible sizes of dimension between which actual size of dimension is contained. The greater of this is called maximum limit or upper limit, and the smaller is minimum limit or lower limit. Here you can see hole having upper limit and lower limit of hole. Here shaft showing upper limit and lower limit. The green line showing the basic size, and these two lines are actual sizes of hole and shaft. So let us see what is meant by fit. So setting limits and tolerances is for to achieve the required or desired fit of mating part. So here the definition of fit is the degree of tightness or looseness between two mating parts is called as fit. So here there are three types of fits: clearance fit, transition fit, and interference fit. Here the diagram showing hole and shaft is mating, in that they are showing their tolerance zones, but this kind of fit is having clearance fit. So in further lecture we are going to discuss the all three types of fits. So let us see what is meant by tolerance or why tolerance is required. So before going to know the definition of tolerances, let us see why tolerance is required. Why tolerance is important as the industrial point of view or in manufacturing point of view. So let us see why tolerance is required. Tolerance is required to achieve required fit. Yes, it is required for to achieve the required fit because no two parts can be produced with identical measurements by any manufacturing processes. In any production process, regardless of how well it is designed or how carefully it is maintained, a certain amount of natural dimensional variability will always exist. Some variability in dimension within certain limits must be tolerated during manufacture, however precise the process may be. So the permissible level of tolerance depends on functional requirements which cannot be compromised. No component can be manufactured precisely to a given dimension. It can only be made to lie between two limits, that is upper limit or maximum limit and lower or minimum limit. So the definition of tolerance is the difference between upper and lower limit is termed as permissible tolerance. So as we have seen, it is very difficult to manufacture components with the same level of accuracy over different range of batch. Moreover, it would require high level of expenses to maintain this level of accuracy. So thus we can say that due to the inherent variation in manufacturing, it is always essential to provide two limits, that is maximum limit and minimum limit, to permit the variations in the manufacturing. So this particular graph showing manufacturing cost versus work tolerances. Why the work tolerance is given to reduce the manufacturing cost? Let us see. So as you can see in graph, as the permissible work tolerance decreases, it increases the manufacturing cost exponentially. You can see here. And when permissive tolerance limit are realized without degrading the functional requirements. So we can't tolerate the functional requirement. To maintain functional requirement, we have to reduce the tolerances, or we can increase the tolerance zone. The manufacturing cost get decreases. So in most of engineering applications, any component manufactured is required to fit or match with some other component. The correct functioning of two component of a part required to fit or match with some other component, or the correct mating relationship between them. This mating relationship is termed as fit. So the desired fit can be obtained by keeping one component constant and varying the size of other component. Also, to facilitate this mating relationship, the manufacturer should provide with some manufacturing allowances in the form of tolerances. So as we have discussed the tolerances, let us see what is meant by deviation. So it is a definition of deviation. It is the algebraic difference between actual size and its corresponding basic size. It may be positive or negative, or it may be zero. So there are three types of deviations. Let us see the fundamental deviation, second upper deviation, lower deviation. So for hole, there is a upper deviation, lower deviation, and fundamental deviation of hole. Also for shaft, there is a fundamental deviation, upper deviation, and lower deviation of a shaft. So in figure you can see that regarding or with respect to basic size, the fundamental deviation is given. So first of all, let us see the fundamental deviation of a hole. Here you can find out on screen the difference between the lower limit of hole and the basic size is called as fundamental deviation. And you can see the lower deviation of hole is a fundamental deviation. Here you can see that the brown arrow showing the difference between basic size and upper deviation. So you can find out the upper deviation of a hole. Similarly, let us see the deviation of a shaft. Here you can see the green line showing the basic size, and the difference between upper deviation of a shaft and the basic size is fundamental deviation of a shaft. Here it is exactly opposite to the deviation of a hole. Here the lower deviation is lower limit of the shaft, and the difference between the basic size is called lower deviation. So these are the concept of fundamental deviation, upper deviation, and lower deviation. So turning to the basic terminology of a limit and fit. So let us see. Here you can see on screen the representation of a shaft and hole. Here you can see The red zone is showing the tolerance zone of a shaft. Here we can calculate the tolerance of a shaft by minimum diameter or maximum diameter minus minimum diameter of a shaft, that is tolerance zone. Similarly, you can see the maximum diameter of a hole minus minimum diameter of a hole. This particular zone is showing the tolerance zone of a hole. Here the line is showing the basic size, and this particular line is called zero line or line of zero deviation. So here we can calculate the upper deviation, lower deviation for both hole and shaft. Here you can see the lower deviation of a hole is the difference between basic size minus the lower limit of a hole. Here upper deviation is a difference between basic size minus the upper limit of the hole. So don't get confused here. So upper limit and lower limit are the two limits of a hole as well as shaft. So while calculating the deviation, we have to take in account the upper limit and maximum limit or lower limit or a minimum limit of a shaft and hole. Here similarly we can calculate the lower deviation and upper deviation of a shaft. So let us see how particularly lower deviation of a shaft is calculated. Here the difference between basic size minus the upper limit of a shaft is called lower deviation, and basic size minus lower limit of a shaft is called lower deviation. So let us start with the terminology. So first definition of a basic size. Basic size, this is the size in relation to which all limits of size are derived. So basic or normal size is defined as the size based on which the dimensional deviations are given. This is in general the same for both components, that is shaft and hole. Here in image you can see the basic size which is defined from the base of hole and shaft with respect to the zero line. So second definition, actual size. The measured size of the job is called actual size. Actual size never be equal to the basic size. So next definition, zero line. The line representing basic size is called zero line. Here in image you can see the zero line or line of zero deviation, which is particularly drawn in between the hole and shaft. With respect to this zero line, all the dimensions, all the tolerances, all the limits are defined. Coming to the next definition, that is hole. So let us see what is meant by hole. The term used to designate all internal features of parts, including those which are not cylindrical, is called hole. That is, they can be rectangular in shape, they can be hexagonal in shape, they can be square in shape. So all the internal feature of a part are called hole. So come to the next definition, that is shaft. The term used to designate all external features of parts, including those which are not cylindrical is called shaft. It is similar to the definition of hole, but these are having the external features, so these are called shaft. They can also be hexagonal, rectangular, square in size. So coming to the next definition, that is basic shaft and basic hole. The shaft and holes that have zero fundamental deviations, the basic hole has zero lower deviation, whereas the basic shaft has zero upper deviation. So these are called the basic shaft and basic hole. Here you can see in image the hole in green color, and in blue color you can see the presentation of shaft. So the next most important terminology is deviation. So deviation is defined as it is the algebraic difference between an actual size and its corresponding basic size. It may be positive, negative, or it may be zero. As we have discussed earlier, you can see in image the fundamental deviation or the deviation, that is with respect to hole, with respect to shaft. You can see the basic size and the sizes of hole and shaft. So let us see the definition of fundamental deviation. So the fundamental deviation, it is the minimum difference between the size of component and its basic size. This is identical to the upper deviation for the shaft. You can see here upper deviation of the shaft, that is the fundamental deviation of shaft, and lower deviation for the hole. Here you can see the lower deviation of a hole is the fundamental deviation of a hole. So it is too easy to understand in this figure. So turning to the next definition, upper deviation. So it is the algebraic difference between the maximum limit of size and its corresponding basic size. This is designated as capital ES for hole and as small es for the shaft. Here you can see the upper deviation of a hole. In brown arrow it is seen that basic size and the difference between the upper limit or the maximum limit of a hole. Similarly, you can see the upper deviation of a shaft, the difference between upper limit of shaft and basic size. So turning to the next definition, lower deviation. It is the algebraic difference between the minimum limit of size and its corresponding basic size. This is designated as capital EI for a hole and as small ei for the shaft. So you can see here lower deviation of a hole at your extreme left. You can see the lower deviation of a hole. Similarly, you can see the lower deviation of a shaft in brown arrow. So next terminology is tolerance. So what is the definition of a tolerance? This is the total permissible variation in the size of dimension, that is the difference between maximum and minimum limits of a size. It is always positive. So mathematically tolerance is equal to upper limit or maximum limit minus lower limit or a minimum limit. So there are 3 to 4 types of tolerances which we are going to discuss in our further lecture. So let us see what is meant by allowance. So definitions of allowance is, it is the intentional difference between. So please focus on a word, that intentional difference. It is the intentional difference between the lower limit of a hole and higher limit of a shaft. And allowance may be either positive or negative. So mathematically it is written as allowance is equal to lower limit of a hole minus higher limit of a shaft. So in figure you can see that hole and shaft meeting with each other and having the intentional difference between the upper limit of a shaft and lower limit of a hole. That particular red arrow showing the intentional difference, that is called allowance. So such kind of fits are called clearance fit, and these are purposefully kept. For example, if we are having any sliding joint, those types of joints are called clearance joint, clearance fit, and such kind of fits are purposefully kept the allowance between them. So that is all about the terminology or the basic terminology of a limit and fit. So including one another point to the terminology, that is designation of hole and designation of shaft in as per the ISO standard. Here all capital letters are designated for showing the size of a hole by uppercase letters from A, B to the Z, and also capital Z to the suffix A, capital Z to the suffix B, capital Z to the suffix C are also used for a hole designation, excluding the letters capital I, L, O, Q, W are not used for hole designation. So such kind of 24 numbers in Indian standards are used for a hole designation system. For shaft, by lowercase letters from small a, small b to the z, and also to the small a, small z to the suffix b, small z to the suffix c are used for a shaft designation. So let us see what is mean by interchangeability. As you can see on a screen, there are number of nuts and bolts kept here. So before going to the example, let us see what is meant by interchangeability. So manufacturing a large number of parts, it is not economical to produce both the mating parts by the same operator. So parts to be manufactured within minute possible time without compromising on quality. To manufacture identical parts, mass production was the idea. The components are manufactured in one or more batches by different person on different machine at different location and are assembled at one place. Manufacture of parts under such condition is called interchangeable manufacturing. So here interchangeability is nothing but we have to manufacture n number of nuts and n number of bolts. Randomly you can select any nut to assemble a nut bolt assembly. You can pick any bolt to assemble any nut. Then you will get the proper mating between them is called interchangeability. Interchangeability is most important term. Because of this you can improve your productivity, you can reduce your rejection rate, you can earn more profit than the conventional one. So in mass production it is highly recommended that the interchangeability improves the product wise quality, also it meets the functional requirement of a particular assembly. So let us see what is mean by selective assembly. In further lecture we are going to discuss about the advantages of interchangeability, and we are going to discuss in brief what exactly the interchangeability impacts on Six Sigma. So let us see first of all what is meant by selective assembly. In interchangeability, we have seen the example of a nut and bolt in a mass production. Here in selective assembly, we are going to discuss the next example of a carburetor manufacturing or assembly of a carburetor. In this, the selective assembly technique is used. So let us see first of all what is meant by selective assembly. In selective assembly, the parts produced are classified into groups according to their size dimension by automatic gauging. So in further lecture, we are going to discuss about what is meant by gauging, what are the types of gauges. Next, both the mating parts are segregated according to their sizes and matched with the groups of mating part are assembled. This ensures protection and elimination of defective assemblies. Assembly costs are reduced as the parts are produced with their wider tolerances. So here in image you can see the gaskets, the needle of a carburetor. Here this particular needle is separated as per the hole tolerance and it is assembled with particular hole which meets the particular functionality of a carburetor. So here, without hampering the functional ability, the selective assembly, with the help of selective assembly, we can achieve the particular functional ability in mass production. So in automotive parts, selective assembly also used. You can see here the n number of parts are placed with differentiating their sizes and dimensions. So it is all about the today's lecture. We have discussed about basic size, then hole designation, shaft designation, tolerances, fits, limits. In further lecture, we are going to discuss in detail about all with example. So this is all about today's lecture. If any queries or doubts, ask in comment below. Thank you. Thank you very much.